All right, everybody. So we are on to week 2, day number 2. So this would be the second day of our class for this week. And just to kind of give you a heads up in advance, as I was looking at the divisibility rules from day 1 of this week, I realized that I didn't give you quite enough of a lead-in about it. So I talked to you about base 10. I did not talk to you about the rest of the assignment. So on the rest of the assignment, it talks about other bases. So you might want to go back and review your bases for the divisibility rules or that homework. Okay, so in other words, it says, will this rule for divisible by 3 work in other bases? In particular, it asks about base 7, base 5, base 6, I think. So let's just talk about 7 real quickly so that everybody makes sure they remember base 7. Okay, so when you should have seen this base 7 stuff in your 350, 351 classes. Hopefully you know what they're talking about. When I talk about any base, I get certain numbers. For instance, in base 10, I get 0 through 9 as my digits. And I know that all of my place values are 10 to some power, right? So whenever I laid those out for you earlier, 1, 10, 100, 1,000, if you were really on the ball, you would have known that this was 10 to the 0, and 10 to the 1st, and 10 to the 2nd, and 10 to the 3rd, right? Okay, so that's the world that we are used to, and what the homework is asking you for from day 1 is to think about, what about in base 7? What about in base 5? What about in base whatever? So I'm going to help you with one of them, and then you're going to have to go back and remind yourself or go get some tutoring or get help somehow. So in base 7, my digits that I get are, what do you think? Instead of 0 through 9, I get 0 through 7 are all of my digits, right? And instead of my place values being 10 to a power, they're all 7 to a power, right? Okay, so when I lay out those place values here, it's not going to be the same as whenever we do base 10. So instead of 10 to the 0, this is 7 to the 0, right? 7 to the 1st, 7 to the 2nd, 7 to the 3rd. So 7 to the 0 is a 1, so that stays the same. 7 to the 1st is a 7. 7 squared, yep, 49. And 7 to the 3rd, I'm pretty sure that's 343, but check me just to make sure. But I'm pretty certain. Okay, so what you're doing here is you're saying, okay, do we think that the rule for divisible by 3 works the same way here? So what you need to do is you need to think about all of these place values and say, hey, what do we want it to be? Is this some multiple of 3 plus a 1? If it is a multiple of 3 plus a 1, then hey, it works the same as it does in 10. So I'm thinking, okay, 1 is 0 plus 1, right? So I think that's okay. 7 is 6 plus 1. So I need to think to myself, is 6 a multiple of 3? Yeah. So you keep going, that's 48 plus 1, and keep on going. So that's kind of the idea. Now don't be fooled. Sometimes it might work for the first one. For instance, this rule will always work for the very first place value, right? Because 1 is the first place value on all of my bases. But it won't always work for the higher place values. So you need to go ahead and do that. And then here's an important point. Just having one example is not enough. So one example isn't enough. So say you pick some base 7 number and So again, my digits are 0 through 7. So maybe I have the base 7 number 643, base 7, and I figure out that, hey, that number is divisible by 3 if its numbers all add up. Actually, this one would not be, right, because 6 and 3 is 9. Plus 4 would be 13. So I think that would be not divisible by 3. And another one would be, how about 603 base 7 would be divisible by 3, we think. So if I find one example or one counterexample, does it work? That's not enough. I can't just come up with one example. What I need is I need to know it works. So prove it. So maybe you might start thinking about drawing some base 7 blocks. That might help you. Okay. So that's my kind of hint for the homework from day 1. And that's about all I'm going to give you on that. So there you go for that. I'm going to go ahead and throw this up here from day 1, the things you should have been doing. You should go ahead and start, if you haven't finished the introduction in chapter 1, you should certainly finish that. And then you should start reading in chapter 2, because before you know it, we're going to be talking about all that algebraic reasoning stuff, which is coming up. In class, we would have completed the number of divisors. So this one, you need to complete it and get it to me. And for homework, you would have had thinking about factors and divisibility. And it sounds like it's a lot, but those aren't really huge assignments. So there's just two little sheets for homework. And again, those need to get to me. You should probably think about the working on your own hundreds board. However, that is not a thing that is due to me. So you're not turning it in. That is for your own benefit. Okay? And then from today, we're about to start in class the crossing the river. So I'm clearly only going to do 1 or 2 examples of crossing the river. You're going to need to go in and finish that whole thing out. So that will be your in-class participation part. So get that turned into me. You need to finish out the GCF and LCM worksheet, but I'm not taking that up. So again, that's for your own benefit. But if you don't do it, then you're going to be left behind on that part. And make sure that you understand the don't fence me in that I'm going to talk to you about. So again, not to turn in, but make sure you know it. Your homework is going to be the building with toothpicks, exploring houses. Normally in class, I would give that as a 2-sided page, so it's 2 separate pages, but it would be a 2-sided thing. Again, it sounds like a lot, but it's just a couple of questions, so look at it real closely. Make sure you understand what's going on, and we'll talk about it toward the end of today's videos. So that's your homework. And then I want you to do the questions from chapter 1, and I've got that loaded up as well in D2L. So that'll be your homework. And in fact, I decided to make it your second project because it'll be writing some answers. If you want to make that into something that you type up, it would make sense to type it up because it's making you think a little bit about stuff that you would do in your classroom. And normally stuff that makes you think about what you would do in your classroom, those would be projects or special activities. So think about that as you go along. All right? And again, I'll make sure everything's clear, I hope, in D2L. Okay. So let's start thinking a little algebraically. Algebraic reasoning. So I'm going to look at this guy right here. It's called crossing the river is the activity that you've got loaded up. I'm not going to do any of the homework questions though, because that is your homework. Instead, I'm going to talk about crossing the river as just a bit of an introduction so that you know what this thing means. So every crossing the river problem, it has something similar in common. This one that I'm going to do for you has 5 men and 2 children on this side of the boat. Oh, sorry, children. On this side of the river with their little boat here. Okay. Now you have to establish some rules. So read through the thing, make sure that you know. The boat will only hold 2 kids or 1 adult. Okay, and of course it could be 1 kid because if it'll hold 2 kids, it'll hold 1 kid. But anyway, so up to, it'll only hold up to 2 kids or 1 adult. Okay, that's all it'll hold. And so I'm standing over here on this side of the river, and I've got 5 men and 2 children. So I'm going to do this as a manipulative-based problem. So I've got some of our 2 color counters back out. So I'm going to make the 2 children be red, and I'm going to make, oh, those were right. I'm going to make the 5 men be yellow, okay? And as this is my river, okay? Dr. Webster's not an artist, never said I was, so, you know, you can make fun, it's okay. Giggle at my drawings, it's all right. So we're going to start over here in our little boat, and we're going to go across the river. So, and I'll draw every time I make a trip so that we can count. The question ultimately is, how many trips to get everyone across? That's what we want to know. How many trips is it going to take us to get everyone across? Okay. And you can count those as one-way or round trips. We'll talk about that at the end. But so I'm going to think for a second, because if it'll only hold 1 adult and I send 1 adult over, then I'm kind of in trouble because the boat's on this side and I can't get it back over. By the way, you can't add stuff to this. I know. I've had people say, I'm going to tie a rope to the boat and pull it back over. I'm going to do that. I'm going to make one of the kids swim across the river. I'm going to do this. You can't do any of that stuff, guys. Okay, everybody's got to cross the river in the boat. There's no bridge anywhere near. They can't go upstream and cross. Sorry. Okay, so they all got to cross in the river or in the boat. And so if I send 1 human, 1 adult over here, there's other versions of this problem where there's dogs and geese and all kinds of stuff. But anyway, if I send 1 adult, then I'm kind of in trouble because the boat's stuck here. The only way to get the boat back across would be to send him back over. That's kind of pointless. If I send just 1 kid over, same thing. It's stuck. I got to send the kid back over. So think about it for a second. A lot of people should probably have the idea pretty quickly. The way to start this problem is to, send 2 kids across. So I'm going to send both kids across in the boat. Okay. And that's 1 trip over. There's my arrow. Okay. That's an arrow, honestly. Not an artist. So I send 2 kids over. The reason I send 2 kids over is because I'm going to leave 1 guy behind, right? And I'm going to make this 1 kid come back across the river with the boat. That's the whole idea. Now, unfortunately, I get a lot of people who say, those poor kids, they're doing all the rowing. And you're right. Hopefully it's got a little motorboat in it, a little motor engine, so that they're not all a motor, so that they're not all rowing. Anyway, so that 1 kid comes back across. Now I can send an adult over, right? Because I know when I send this adult over, for instance, again, draw my arrow, he's going to be able to stay, no problem, and the kid will be able to bring the boat back, right? Okay. So notice that it took 4 one-way trips to get 1 adult all the way across. And we're actually back in the original position where the 2 kids are back on the left-hand side. All right. So maybe we'll start seeing a bit of a pattern as we go along. As I look at it, I say, oh man, so now I'm stuck again, right? I don't want to send this guy over by himself because, again, I got to get the boat back. So this is where the kids start earning their keep, okay? 2 kids over, draw my arrow, 1 kid back, draw that arrow, right? So if you want to think about it, it took all of this to get 1 adult. If you want to think about it like that, maybe that'll help. Okay, now I've got the boat back, so I send 1 adult over. And then I send the 1 kid back with the boat. Huh, look at that. Again, it took 4 trips, right, to make 1 adult go over. So again, take the 2 kids over. take the one boat back. Take the one kid back with the boat. I need to send an adult over. Send the one kid back with the boat. Huh. Again, 4 trips for one adult. I hope you're paying attention at this point, because now we're starting to see a bit of a pattern, I think. So I would like to extrapolate and see what we think is going to happen. What do you think is going to happen? If I want to get one more adult over, then you guessed it, send the 2 kids over, send the 1 kid back. That makes for a round trip right there. Send the 1 kid over, or I'm sorry, the 1 adult over, and send the 1 kid back. Wow, look at there. Took 4 trips to get that adult over. And so I'm thinking we can guess what's going to happen for the 5th adult. We send the 2 kids over. We send the 1 kid back. We send the 1 last adult over. We send the 1 kid back. So, unfortunately, sometimes people start getting a little bit ahead of me, and they say, oh, well, there's 5 adults. Oops, 1 adult there. There's 5 adults. It takes 4 trips per adult to get each adult over, so there's 20 trips. And you're very, very, very close, my friend, if you said that. The problem is what? Yep. The kids are stuck back over here. So poor kids, they've got to row or whatever all the way back across one more time. So in that case, it's interesting because it only takes one-way trip to get the 2 kids over there, right? So if I count them all up, let me come back up here. How many trips to get everyone across? It's 21 one-way trips. Right? 1, 2, 3, 4, and so on and so forth. 21 one-way trips, or if I count 2 one-way trips as a round trip, it would be 10.5 round trips. If you want to think of it that way. I don't care which way you think about it. That's just a bit of what's going on there. Okay? So, as you work your way through the crossing the rivers activity here, you can see what it tells you. I'm looking at the one that I'm going to load for you. It says 8 adults and 2 children need to cross the river. So it's still 2 children, but it's 8 adults. Okay? How many one-way trips? And then you have to draw a picture, so you have to be an artist as well. And then there's some other stuff that happens on the back of that page. 6 adults and 2 children. 15 adults and 2 children, 3 adults and 2 children. What if it was 100 adults and 2 children? Clearly, I don't want to draw a picture for that one, right? Because it's 100 adults. Write a rule for finding the number of trips needed to get any number of adults, A, so this is number 4, and 2 children across the river. So, I'm not going to tell you what that is, but hopefully you see a pattern. We kind of got it. Then there's some extra challenges. What if there were 3 children? What if there were 5 children? So think about those. I think that'll get you going for what in the world's going on with the children. Okay? So that's my thought on that one. All right. You need to finish that and get it to me, crossing the river. Now, we need to do a little bit of note-taking. So, here we go. I'm going to stop this video because I see it's at 19 minutes. And then I will start another video that will be your second video for day 2. And we should be able to wrap everything up pretty quickly, I think, doing that. All right.